Aquaponics combines aquaculture with hydroponics to grow fish or other aquatic animals and plants together. Aquaculture is a means of farming fish under controlled conditions. Hydroponics is a means of growing plants without soil. In aquaponics, the aquaculture and hydroponics subsystems are treated as separate components of a unified aquaculture system. Aquaponics creates a symbiotic environment where both fish and plants benefit. In a well-balanced system, the plants get most of their nutrition from fish wastes, and the fish get clean, filtered water back from the plants. Bacteria are the catalyst in the aquaponics system. They live in the system, wherever water comes in contact with other components. Some bacteria convert ammonia from fish effluent into nitrates, and then others convert those nitrites into nitrates. Plants are able to absorb nutrients through their roots as nitrates after the bacteria has converted them into that form. There are lots of different ways to configure aquaponic systems. Plants grown using hydroponic methods are commonly grown in beds or pots filled with clean, inert materials such as gravel, or grown in NFT channels where roots are suspended in pipes with a constant flow of water through those pipes. Aggregate culture involves growing in a solid, inert material, such as scoria, gravel, sand, expanded clay, or perlite. Inert means that the material is free of nutrition and clean, that is, free of microorganisms. Water from the fish tanks is periodically pumped into the media, keeping the roots supplied with moisture and nutrients. With NFT or nutrient film technique systems, plants are grown in PVC channels without any media. Water enriched with nutrients from the fish tank is constantly pumped through a pipe. The enclosed environment keeps humidity very high, and roots hanging in the pipe can grow in or out of the water flow. Sometimes the fish may require different conditions to the plants. This might be in terms of light, temperature, or something else. The NFT channels can be used either as a horizontal garden or a vertical garden. They may be set directly above the fish tank, or the water could be collected at the end of the channel and then piped to a fish pond or tank wherever you choose to locate it. In other systems, plants can float on the surface of separate water tanks or ponds with their roots protruding into the water from some sort of floating raft. Some systems may have multiple water tanks. Other systems may have multiple beds for growing plants. Some systems grow plants in a vertical garden, then collect the runoff in a fish tank below. Most aquaponics systems are closed systems where the water is recirculated between the fish tank and the grow beds. The same water continuing to go round and round the system. Fish are kept in a separate tank where a pump oxygenates the water. Here they are fed and they release their wastes into the water. Water from the fish tank is then pumped into the grow beds. The large surface of the media provides a home for bacteria to thrive, and conversion of waste into nitrates takes place there. In more sophisticated systems, the conversion of waste products to nitrates takes place in a separate biofilter tank before the water is passed into the PVC channels or beds which support the plants. Filtered and oxygenated water from these systems is then allowed to drain back into the fish tank. Water in the system is only replaced periodically or if it becomes contaminated.